All right, today's notes is 2.4, part 1, the chain rule. The chain rule. If y equals f of u is a differentiable function of u, and u is equal to g of x is a differentiable function of x, then y equals f of g of x is a differentiable function of x. And dy over dx is going to be equal to dy over du times du over dx. Or better yet, the derivative of f of g of x, you take the derivative of the f first, which is the outside function, keep everything inside the same, then you're going to multiply by the derivative inside. So always take the derivative outside, keep the function the same inside. Then you're going to take the derivative of the function inside. For example 1, I'm going to rewrite this. Y equals 1 over 2x plus 1. This is the same as saying y equals 2x plus 1 raised to the negative 1 power. Now, what I'm going to do, this is the chain rule. When you take the derivative of y is going to be y prime. Now, I'm going to bring this negative 1 down to the front. So I'm going to write negative 1. You are going to keep the function the same. So keep the function the same. So I'm going to keep the 2x plus 1 on the inside. And then I'm going to decrease this power by 1, which is negative 1 minus 1 is going to be negative 2. So I took the derivative outside. Now I'm going to multiply it by the derivative inside. So take the derivative inside. The derivative of 2x is going to be 2, and the derivative of 1 is going to be 0. Now to clean this up, you have y prime, which is the same as saying dy over dx. Y prime is the same as saying dy over dx. Y prime is the same as saying dy over dx. In the numerator, you are left with negative 1 times 2, which is going to be a negative 2. And then because that's a negative exponent, all of this goes to the denominator. You cannot plug this into the calculator because I'm not giving you an x value to evaluate it at. So take the derivative outside, which means you are doing the power rule. So bring down the negative 1, decrease the power, keep the inside the same. Then you're going to take the derivative inside because you already took care of the outside. Okay, the derivative of y is going to be dy over dx. You take the derivative outside. The derivative of sine is going to be cosine. keep the argument the same. Keep the argument the same. Now you take the derivative inside. And the derivative of 2x is going to be a 2. Now this is technically correct, but if it were multiple choice, that's not the solution that's going to show up. The solution that will show up is going to be a 2 cosine of 2x. Do not multiply the 2 to the 2x because this is cosine 2x. That's the argument. You can't take the 2 and multiply inside the argument. All right. For letter C, the derivative of y is going to be dy over dx. Now you're going to take the derivative of the outside. So you're going to take the 3, move it down to the front. So that's going to be a 3. Keep everything inside the same. Keep everything inside the same. So I'm left with x squared plus 3 on the inside. And then don't forget to decrease your power. So now instead of it's 3 minus 1, so that now that's a power of 2. I'm done taking the derivative outside. Now I have to take the derivative inside. The derivative of x squared is going to be 2x. And then the derivative of 3 is going to be 0. So I don't need to put that there. On a multiple choice test. Now this is square, so leave this alone. X squared plus 3 squared. But you can multiply these. 3 times 2x, which is 6x. On D, I'm going to go ahead and I'm going to rewrite this. This is the same as saying y equals 4x squared minus 3x plus 1 raised to the 1/2 power. Go ahead and try to take the derivative here. Press pause and take the derivative here. So now here, when you're taking the derivative of y is going to be dy over dx. I'm going to go ahead and bring the 1/2 to the front. So this is going to be a 1/2. Keep everything inside the same. Keep everything inside the same. And then when I decrease my power, 1/2 minus 1 is going to be a negative 1/2. Now I took care of the outside. Now when you're taking the derivative inside, make sure you're putting that in parentheses. So the derivative of 4x squared is going to be 8x minus the derivative of 3x is going to be 3. And then the derivative of 1 is going to be 0. Now when you're cleaning this up, that 2 is a denominator. This right here is a denominator because you have a negative exponent. So we have a 4x squared minus 3x plus 1. Now it's going to be raised to a positive 1/2. And then this 8x minus 3 is a positive exponent. There's a 1 here, you just don't see it. So that's going to be 8x minus 3. Now you can leave your answer like this, or I can write this as a radical in the denominator. More than likely, this will be the answer on a multiple choice test. Make sure the radical is over the 1. Do not try to reduce this 8 and this 2 because that says 8x minus 3. So you have to subtract the 3 before anything. Now, if this was an even number, then you would reduce each of these by 2, but it's not. So you have to leave it like this. So the general rule here is if y equals u to the x raised to the n power, where u is a differentiable function of x and n is a rational number, then the derivative of y, you bring the power of n down, you keep the function inside the same, you're going to decrease the power, then you have to take the derivative inside, and the derivative of u is going to be a du over dx. Or equivalently, if you have the derivative of u to the n, you bring the n down, you decrease the power, and then you take the derivative of u. So right here, we're going to go ahead and take the derivative. The derivative of f is going to be f prime of x. I'm going to bring the 3 down to the front. So that's going to be 3. Keep everything inside the same. 3x minus 2x squared. And then you're going to decrease this power. So 3 minus 1 is going to be a 2 times. Now the derivative inside. Keep that in parentheses. The derivative of 3x is going to be a 3. The derivative of 2x squared is going to be a 4x. And you're done right here. You cannot simplify anymore. You might want to distribute the 3, but don't do that, because then what's going to happen is that 3 is going to be a GCF of these two factors. And then this is all squared, and order of operations always says to do exponents before you can multiply. So that would be your final solution there. I'm going to rewrite this. This is the same as saying f of x equals x squared minus 1 raised to the 2/3 power. The power is 2, the root is 3. So now when I take the derivative, I have the derivative of f is f prime of x. Then right here, I'm going to go ahead and this 2/3, I'm going to move it out to the front. I am going to decrease it by 1. So when I bring it out to the front, that's going to be a 2/3. Keep everything inside the same. X squared minus 1. And then 2/3 minus 1 is going to be a negative 1/3. Now I have to take the derivative inside. The derivative of x squared is going to be 2x, and the derivative of 1 is going to be 0. So now to clean this one up, the 2 and the 2x, those are numerators, because this is going to go to the denominator because of the negative exponent. So 2 times 2x is 4x. And in the denominator, I'm left with a 3. And then that power of 1/3 is actually a cube root, I mean. All right. On this one, I'm going to rewrite this. This is actually a negative 5. And this is going to be a 3x minus 2 raised to the negative 4th power. The derivative of h is going to be h prime of x. Now you already have the -5 there. So you're going to bring down the -4. So I'm going to multiply the -5 by -4. I'm going to keep this the same, which is a 3x minus 2. And then -4 minus 1 is going to be a -5. Then you're going to take the derivative inside. So the derivative of 3x is going to be a 3, and the derivative of 2 is going to be 0. Now, you are multiplying. The -5 and the -4, those are numerators, and so is the 3. The only thing going to the bottom is this piece because of the negative exponent. -5 times -4 is +20. +20 times 3 is going to be 60. And then this right here is going to be a denominator. And instead of a -5, it's going to be a +5. That's why it's in the bottom. On D, I'm going to rewrite this one. This is going to be an x cubed times a 1 minus x squared raised to the 1/2 power. Now, because you have two x's, you're going to have to do the product rule because you are multiplying here. So on this one, you're going to have to apply the product rule. And in the product rule is going to be a chain rule, okay? So right here, I'm doing the product rule because here I have an x and here I have an x, and I'm being multiplied. So this is one function and this is another function. That's the difference. That's one function, that's another function. So now doing the product rule, you keep the first one the same. So I'm going to keep the first function the same, which is going to be x cubed. Now, I'm going to take the derivative right here. On this one, you are doing the chain rule. So you're going to bring the 1/2 to the front, keep everything inside the same, decrease the power. So 1/2 minus 1 is going to be a -1/2 times. Now the derivative inside, the derivative of 1 is 0, and the derivative of a -2x is going to be a -2x. The derivative of x squared, sorry, is -2x. Plus, now I'm going to keep the second function the same and take the derivative of the first one. And the derivative of x cubed is going to be a 3x squared. So this is basically the u, this is the v prime, this is the v, and this is the u prime. Now be careful when you're cleaning it up. So now when I'm cleaning it up, you see all of this right here, that's all one term. Now these 2's are going to cancel each other out because that 2's a numerator and that 2's a denominator. Now I have a x cubed here, I have a 1, that's going to go to the bottom, and a -x. So I'm basically taking x cubed and dividing it by multiplying by -x, so that's going to be a -x to the 4th. And then this exponent is going to make this into a denominator, and because it's a 1/2, it's going to be a square root. Plus, now right here, that's going to be a 3x squared, and that's just going to be a positive square root. You do not have to get common denominators. You can go ahead and just leave it like this. Now, let's say that answer does not show up. If that answer does not show up, then maybe they did get common denominators. So if we have to get common denominators here, I need a square root of 1 minus x. So I'm going to multiply the top by 1 minus square root of x and the bottom by square root of 1 minus x squared. So now the denominators match. Now in the numerator, you're left with a -x to the 4th plus 3x squared. Now, right here, when you multiply a radical times a radical is a radical square, which those cancel out. And you're just left with what's under the radical, which is the 1 minus x squared. Now, when you are simplifying the numerator, that's going to be a negative x to the fourth. That's going to be a positive 3x squared. And that's going to be a negative 3x to the fourth. These are like terms, and that's going to be a negative 4 x to the fourth plus 3x squared. So if this answer doesn't show up, then this answer will show up. Now on this one, you can actually solve this using the quotient rule. I'm going to go ahead and I'm going to do the quotient rule on this one. The numerator is going to be a 2x. The denominator is x squared minus 5 raised to the 1/3 power. So it's a quotient rule because you are dividing. Technically, you can actually move that to the numerator and just put a negative 1/3 power and then do the product rule and it'll still work. Now on the quotient rule, the derivative of f is going to be f prime of x. It's going to be low d high subtract high d low. So low, keep the low the same. Keep the low the same. Now d high, the derivative of the top is going to be a 2. Subtract. Keep the high the same. Now when you're doing d low, you are doing the chain rule here. The d low is a chain rule. So bring the 1/3 to the front. Keep everything inside the same. Decrease the power. So 1/3 minus 1 is going to be a negative 2/3 times the derivative inside. The derivative inside is going to be a 2x. All over the bottom square. Now I'm going to clean this up. That right there is going to be a 2x squared minus 5 raised to the 1/3. Subtract. Now right here, the 2x and the 2x, those are numerators. So that's going to be a 4x squared. That 3 is going to be a denominator. And this right here is going to be a denominator. X squared minus 5 raised to the 2/3 power. And then right here on the bottom, you're multiplying that. So 1/3 times 2 is going to be 2/3. Now, if you look at your numerator, you need common denominators here to combine them. So this denominator needs to match this one because right now it's over 1. So I'm going to multiply the left side by a 3x squared minus 5 raised to the 2/3 power. And whatever I do to the bottom, I'm going to do to the top. This is still the bottom. Now my denominators match each other. So that's going to be a 3x squared minus 5 raised to the 2/3 power. And now on the top, this is what I'm left with. So I'm left with 2 times 3, which is going to be a 6. And then right here, these are the same bases, x squared minus 5, x squared minus 5. So I have to add the exponents, and 2/3 plus 1/3 is going to be a 1. So you're just technically left with just x squared minus 5 raised to the 1 power minus 4x squared. In the numerator, that's going to be a 6x squared minus a 30 minus a 4x squared. You need to combine like terms. I'm going to keep these two the same. And then right here, 6x squared minus 4x squared is going to be a 2x squared. Now I have a fraction. I'm going to make this over a fraction. The outside goes on the top, which is going to be the 2x squared minus 30. The inside, which is the 3x squared minus 5 raised to the 2/3. And x squared minus 5 raised to the 2/3, those go together. Those are the same bases. So those need to just add the exponent. So 2/3 plus 2/3 is 4/3, which reduces. So then the final answer, the numerator is going to be a 2x squared minus 30. The denominator is going to be a 3x squared minus 5. 2/3 plus 2/3 is actually 4/3, sorry. Almost done. I need to do the chain rule. So the derivative of y is going to be y prime. Now for the chain rule, you are going to bring the 3 down to the front and then decrease the power. Keep everything inside the same. Keep everything inside the same. And then I'm going to decrease the power, so now the power is 2. Now, I took the derivative outside. When you take the derivative inside, well, guess what? You have a fraction here. You are going to have to do the quotient rule. You're going to have to do low d high, subtract high d low. So low, keep low the same. D high, the derivative of the top is just going to be 3. Subtract, keep high the same. And then D low, the derivative of the bottom is just going to be -2. All over the denominator square. So right here, 3 times 4 is going to be a 12. 3 times -2 is going to be a -6x. -2 times 3x is going to be -6x. -2 times -1 is going to be a +2. Negative times a negative is going to be a +6x. Negative times 2 is going to be a -2. So now when you're combining like terms, the 6x's cancel, and then 12 minus 2 is going to be a 10 in the numerator. Now this answer may show up. Or, do you see how both of these are 4 minus 2x's? Well, that square belongs in the numerator and the denominator. So if the denominator is square and that square, you now have 4 on the bottom. You're now going to have 4 on the bottom. And in the top, you're going to have a 3 and a 3x minus 1 square, and then you also have the 10, which means you have a 30 times 3x minus 1 square all over 4 minus 2x to the 4th. That answer might show up. So transcendental functions and the chain rule. If you are taking the derivative of sine of u, you have to take the derivative of sine, which is going to be a cosine u, and then take the derivative of u. Take the derivative of the argument. So take the derivative of sine, which is cosine, keep the argument the same. Then take the derivative of the argument. The derivative of cosine u, the derivative of cosine is negative sine. Keep the argument the same, and then take the derivative of the argument. Now the derivative of cosecant is going to be negative cosecant of the argument, cotangent of the argument, times the derivative of the argument. So it's cosecant of the argument and cotangent of the argument, and then don't forget it's negative. And then the derivative of the argument. The derivative of secant is going to be secant u tangent u, secant u tangent u, and then take the derivative of the u, the argument. And lastly, the derivative of cotangent is going to be negative cosecant square of the argument times the derivative of the argument. Now let's say you have e. Remember that the derivative of e to the x is e to the x. However, right here, if you have e to some power, it's going to be e to the power times the derivative of the exponent. All right, and that concludes our notes.